Okay, empirical formula calculation. The empirical formula of a compound is essentially, it's in the 18th, 19th century, they started to measure how much of each particular, element, thing would combine with other things. And it was based on observation, calculations based on observation, that led to the initial formulae for different compounds. Okay, so empirical essentially means that something is based on observation. Empirical evidence, it's based on something you can observe, something you can measure. The empirical formula of a compound, this is something for you to remember, is the simplest whole number ratio of the elements present. The simplest whole number ratio of the elements present. That's the definition you need to know. We can work out the empirical formula using the following process. So, for example, imagine we have a compound and we know there are 24 grams of carbon in the compound and there are 64 grams of oxygen in the compound. Okay? We could use percentages here, but we'll see an example like that later on. So what we do, the first step is we divide by the relative atomic mass, the number we get from the periodic table, the relative atomic mass. So 24 divided by 12, 64 divided by 16, there's the numbers. We obviously have to simplify that ratio. We get 1 to 2, and then we know the ratio of carbons to oxygens, so we can write the empirical formula for the compound, which is obviously here CO2. Okay, it's a nice simple example. Let's look at another couple of examples. Imagine 1.2 grams of magnesium ribbon is completely burnt to produce 2 grams of magnesium oxide. So from this data, and you can do this calculation from an experiment you do in year 10 in class, you can work out how much magnesium and oxygen you have. So in this case, we've got 1.2 grams of magnesium at the beginning, and we make 2 grams of magnesium oxide. So if the thing that's been added is the oxygen, then how much oxygen have we got? How much oxygen have we added? Well, it's going to be the 2 grams of the magnesium oxide subtract the 1.2 grams of the magnesium that we started with to give us 0.8 grams. Okay, let that sink in. Does that make sense to you? Then we divide by the relative atomic mass as before. Write the numbers down. Bam, bam. That's nice and easy. And then the simple ratio is 1 to 1. So what's the empirical formula of the magnesium oxide? It's MgO. Okay. Now a little point to note here is that the empirical formula of an ionic compound is always the same as its formula. The formula of an ionic compound, NaCl, MgO, CaCl2, is always the simplest ratio of the elements present. Okay. Here's another example using percentages, but we can do it exactly the same way. By using percentages, all we do is we express the percentages. It's almost like it was a mass, basically. So 80 and 20. Divide by the relative atomic mass, divided by 12 for carbon, divided by 1 for hydrogen, and we get those numbers, which when we do, one of the ways that you can simplify a ratio, I'm not here to teach you maths, but at the same time, I'll make sure you understand how to do it. If you want to simplify ratios, one of the easiest ways of doing it is to divide by the smallest number. So which of these two is the smallest number? 6.67. So divide 6.7 by 6.67, you get 1. And if you divide 20 by 6.67, you get 3. Okay, so divide by the smallest number. It's a little mathematical trick. Carbon, hydrogen, 1 to 3. So the empirical formula is CH3. The simplest ratio. Now this doesn't exist as a compound. It wouldn't work. But this is the simplest ratio of the elements present. We're going to have to take this empirical formula and we're going to have to make it into a molecular formula, and that's the next stage. Now, if we need to calculate the molecular formula, we need the relative molecular mass. It will always be given to you. Okay? So in the previous question, the empirical formula was CH3. So we're told that the relative molecular mass of the compound is 30. So we have to work out what the molecular formula is. The first thing we do is we find out the relative mass of the empirical formula. Carbon and hydrogen, 1 carbon, 3 hydrogens, so 12 plus 3 times 1, 15. Fantastic. Once we have the relative mass of the empirical formula, we divide the relative molecular mass, which will be given, by the relative mass of the empirical formula. And we get what we could call a multiplication factor. So if the relative molecular mass is 30, the mass of the empirical formula is 15. 30 divided by 15 gives me 2. We're going to call that our multiplication factor. And we're going to use the multiplication factor. We're going to multiply this by the empirical formula, and that's going to give us, so we've got the multiplication factor of 2. The empirical formula is CH3. If I multiply everything in that formula, 2 times C and 2 times H, so 2 times 1 is 2, 2 times 3 is 6, I get the molecular formula C2H6. It's again mathematics, distribution of this 2. So I've now got 2 carbons and I've got 6 hydrogens. Okay? And that gives me the molecular formula. Right, you ready for some questions? Read the pages indicated and do the questions.